So it seems we can start. I pass the floor to Hedy Carey that will introduce you to the roadmap.
Thank you. Hello, everyone. So this session is as the topic, the OntoCommons Roadmap. The roadmap is one of the main outcomes of the project. So we start with introducing the context of this roadmap and the expected impact of this roadmap for industry, because it's an effort that we run based on open, let's say, consultation by collecting the industrial needs. So in this roadmap, we are focusing on ontology commons ecosystem for ontology-based data documentation. So there is, let's say, three main topics. First one is ontology foundations, including top reference, middle, domain, and application levels ontologies. Then second part, including the development environment, so the tools for ontologies and infrastructures. And the third part on the industrial impacts, including marketplaces, standardization, education, and human resources. So each chapter in the roadmap includes industrial needs, the state of the art, the identified gaps, definition of access, and the recommendation actions. So on all those topics, this is the structure of the roadmap. This is the what we published already is the first version of the roadmap, and by the end of the project, we'll publish the final one. So that's why we would like to share our finding there, and also to discuss with the community regarding the content and collect more feedbacks and thoughts regarding those different topics. Um, so as industrial impact, so what we really we are looking for is that, let's say, the adoption of ontology. Uh, the adoption of ontology as a basic data documentation and knowledge management practices in industry, unfortunately, is still at low level. So let's say we are looking to reach wider impact. That's why let's say, we can, with AutoCommons, trying to show the benefit that we can have from using ontologies for data documentation in industry. So it can be also a tool in order to have business value. So this is our main context of the roadmap. Also, what we are looking for is not to have benefits for individual companies, but to have this cross-domain opportunities and data sharing in what we call the industry commons, so an ecosystem for industry commons to reach interoperability cross domains and cross companies, enterprises. So we believe that the system of digital marketplaces can support needs such as data integration and interoperability, and also for improving data transfer. So this is the different chapters of the roadmap. This is the structure. As I said, I mean, needs, state-of-the-art, gaps, definition of success, and recommended actions for each chapter. So the rest of the presentation will be ensured by colleagues that led the different chapters of this roadmap. So the first one is the top reference ontology. So I'll invite Emanuele Ghedini from Enigo to present.
Thanks, Eddie. In chapter 3.1, we address the top reference ontology, which is the part of the OntoCommons ecosystem that propose a set of top-level ontologies together with the alignment between them in order to create a probabilistic perspective that allow to host ontologies belonging to different top-level of reference. So what this part of the ecosystem can provide, what type of needs can address. For example, the first one is covering the gap between human and digital tools, because an ontology is something that is understandable by human beings, but it's also computable, processable by digital devices. It also can improve interoperability between standards, vocabulary, data, and software tools, and promoting innovation via multidisciplinary interaction. It can also provide a ground for better format for standards and vocabularies if standards and vocabularies are expressed using an ontology. They will start to be based on logical-based framework, so providing a constraint and finding maybe inconsistencies between standards. Can provide the ground for effective data documentation, and also the possibility to promote knowledge-based reasoning as opposed to generic AI in order to facilitate the adoption of AI solution for industries. But what are the gaps that prevents the preference part of an ontological framework to be effectively used? For example, the first gap can be related to the fact that ontology developers do not invest in the overhead needed to align with the top-level ontology. Nevertheless, if you ask an ontologist, they usually say that a top-level ontology is good in order to provide a consistent framework. There is also a cross-disciplinary gap between ontologists and people working in the domain. So people doesn't know exactly what an ontology is, what are the motivation behind a specific top-level ontology. There is also the lack of inter-top-level ontology connection, because usually top-level ontologies are expression of a community, and these communities usually do not interact too much. There is also a lack of high-level tools for top-level ontologies or mid-level ontology engineering. So there are not a lot of professional tools that facilitate the development of such of ontologies based on a top level. And also the computer power that is available nowadays is not, in my opinion, harvested like is done in other fields, like, for example, modeling and simulation. And also, there is a lack of multidisciplinary competencies. So there are not enough professional figures that bridge between the domain and the semantic technologies. And the recommended action that are try to cover this gap, and goes from, for example, the definition of adoption route and good documentation to promote the use of top-level ontologies, stimulate the communities, top-level communities, to work together and to develop alignment, like we are doing in OntoCommons for 3 top-level ontologies, to promote scalability in the use of ontologies. So it's not always necessary to be extremely detailed with ontologies. You can also sometimes be high level in order to save computability in spite of expressivity. We also need to aware to make policymakers aware of the fact that we are lacking of tools, and promote education and training. For example, clear communication about what an ontology can do or cannot do, and also look for education and training opportunities and incentives for the use of ontologies in an industrial field. And that's essentially all.
Thank you, Emanuele.
Thanks.
Thank you. So I will continue with another topic related to ontology. So let's keep the questions for the end of the session. The next chapter is concerning the domain ontologies. So regarding that, let's say domain ontologies are needed for data integration and sharing. And one of the most important information that we collected, that 70% of the people that we survey, they say that they are really interested to ontologies for data integration and sharing. Also, ontologies need to be confident when use that, so they trust standards. So they need to have standards regarding domain ontologies. So let's say it's provide more confidence when using ontologies. But one of the problems is that when let's say the timeline for standards development is a little bit long. So also what we highlight is that for industrial there is various domain perspectives. So in the same domain there is different perspectives. Like, for example, in maintenance, we have maintainers, we have people that define strategies, we have predictive maintenance. So there is different perspectives within the same domain. So all of those perspectives should be, let's say, aligned and interoperable in order to ensure a chain of exchange within the same domain. Also, one of the needs is to interface domain ontologies with top-level ontologies, and also link domain experts with ontologies. So if we would like to link with TLOs, we need ontologists. We need to bridge there is a gap between both profiles. So when we conducted the state of the art on domain ontologies, we collected more than 200 ontologies. And this is a sample of the domains that we deal with, and the evaluation that we conducted. So as you can see, for the FAIR principles, it's a little bit low on the existing ontologies. Also, the use of top-level ontologies is quite limited, and also one of the, let's say, surprising information that we identified, that there is a lot of ontologies that are not machine readable. So they are only existing on publications. So this is one of the gaps that we identified. So from ontology perspective, domain perspective, the gaps is on the granularity aspect. So the model's granularity of the ontology, especially when we talk about manufacturing and materials. Also, one of the gaps is the lack of generic and application-specific ontologies. So there is this hierarchy of ontologies, how we will move from a generic and the application, how to separate the public and the private ontologies, which is specific for local needs. The lack also of standardized methodology and tools. This is also one of the gaps that we identified, and many industrials, they are highlighting this. Okay, which methodology I have to use, which tools, all of this is identified. Also on the, let's say, ontology as conceptualization of reality versus information model. This is a big debate between people working on ontologies. So we need to well formalize and to explain this difference and how we exploit it. The ontology sustainability also is one of the gaps, because a lot of ontologies have been developed in projects and with big effort from the community, but after the end of the project, ontologies are not maintained, are not available, are not accessible. And let's say, for me also, is part of the most important gaps is the lack of standardized method for domain ontology evaluation. So to say this is a good or not, if the community will accept, okay, what are the criteria? What is the quality of this ontology? So this is another gap. So for that, we identified some recommendations. Let's say that one of the most important, from my perspective, is the standardization of the ontology engineering steps. So we need standard for that, and also make the balance between the theory and the practice. People who are handling data that will use the ontology, and people that are on the theoretical aspects of ontologies, we need, I mean, one of the most important actions is to make and to bridge the gap between them, and also push people to develop fair ontologies. So that's all from the ontology, domain ontology perspectives. And the next chapter is about the tools. So Lan, please.
Thanks, Hadi. Good afternoon, everyone. My name is Lan Yang from the University of Galway. I'm going to explain the ontology commons ecosystem toolkit. So this toolkit consists of the most state-of-the-art methodologies, references for tools, and guidelines for implementing such methodologies and tools. We think this tool design is based on, well, to the best of our knowledge, based on the very extensive surveys and analysis of existing methodologies, existing tools, And we had a lot of consultation and collaboration with experts and practitioners from both industry and academia. By consulting them, like the ontology practitioners, tool developers, tool users, and ontology users, we learned that there is an urgent call for a better tool ecosystem for ontology engineering, for the whole life cycle of ontology engineering. And we divided them into two parts, functional and non-functional services. In terms of functional services, there is a requirement for a tool ecosystem that can support all the phases and all the activities happening in the ontology engineering lifecycle. To be specific, this toolkit should integrate a set of components that can perform specific tasks happened in the ontology engineering and use lifecycle. And in terms of non-functional services, we found that the industrial stakeholders expect this toolkit architecture can be very flexible, and it should have the ability to integrate different tools and have a very interoperable interface to allow domain experts to participate in the whole process of developing ontologies. So a third need in this non-functional services is that we found there is a very, very important call for collaborations. So during the process of ontology engineering and use, there are many users, many developers, experts contributing to this process. And we want an ecosystem that can collaborate all of the people who have been contributing to the development. So this ecosystem toolkit should also be a collaborative environment. And the last point was this tool ecosystem needs to consider the FAIR principles, which is very important because it deals with the important phase of ontology publication. So regarding the gaps, we analyzed the existing ontology tools from surveys, and our finding was often domain experts found it very hard to understand and work with the existing tools, and the options are very limited, especially for concept identification, constraint specification, test specification, visual drafting, navigating ontologies, and ontology visualization. Myself, I'm a very visual person, so I can't agree more on this. And we, for all the ontology engineering phases, we found there is a big gap in ontology validation. That's why we have a dedicated session on day 3 to discuss this issue. And this was found from the survey that there are not so much consideration on generating linked data for data validation, and the shackle shapes were not widely used for RDF knowledge graph validation as well. And for the existing tools, we found there is very limited integration to ensure all the tools can be used in a chain. So this is one of other topics that will happen on day 3 to discuss. For the recommended actions, we think we should meet the industrial needs, of course, and considering the current state-of-the-art ecosystem, we want to recommend people to contribute on principles, best practices, and methods for creating and maintaining ontologies. The future work should also considering identifying the missing aspects in this tool ecosystem. We want to promote industrial portal as a very important component in this toolkit because it can make ontology adoption easier and more meaningful. My last words was, I think we should work all together towards a methodological framework that can provide a very user-friendly and a very practical tool ecosystem for reusing data across multiple domains. Thank you.
Thank you, Lan. So the next chapter will be also on the same, let's say, topic, talking about the infrastructure, also related to ontologies. So, Florina, please.
Thank you, Heidi. Hello, I'm Florina from TU Wien, and we've been working on the infrastructure chapter of the roadmap. Okay, thank you. So, as an introduction, what do we understand by infrastructure? We've heard these words today quite a lot. So what generally infrastructure is a set of systems and services which is absolutely necessary and basic for something to function, like the public transportation in this city. Yeah, you need the roads, you need the railroads. In this project, in OntoCommons, we limit this to research infrastructure, and this is defined by Article 2 in the EU regulations. And some of the components, the main components we consider in this roadmap are the hardware, the physical networks, the software stack you need to run your services, the APIs to access them, and of course, very importantly, organizational aspects. What are the rules of participation? What are the financial regulations to access the infrastructure? And of course, human resources. So I don't know what happened. Okay. No, that's two more. The needs, the industrial needs. Yeah. So we've heard in the morning today quite a lot of requests. Yeah, what demonstrators would need for their work to be more fluid and more efficient. So. Out of all these workshops and collaborations and communications we've had over the last years, we crystallized these 4 points. So first of all, we do need secure collaborative tools for multiple stakeholders, and they should be inter-organization, so different partners in a project collaborating, and I'm not thinking now research projects, but also industrial projects. We need this was really very important for lots of people we've spoken with. Interactive visualization of the data makes understanding what the data is about easier. You identify trends, and we should be able to interact with it. Then another critical need for industrial partners is that the data quality and assurance and analytics, data validation should also be available. Yeah, and here we also think of, for example, automatic processing of the data to detect points of non-compliance in the operational pipelines, for example. And at the same point, we also need some kind of metrics to measure the level of quality, reusability, data documentation, and of course, verification of the data should contribute to this. Last but not least, trustworthy data repositories, trusted computation. Things should not leak out of the environment of collaboration. So, based on these needs, we identified these gaps and related to the infrastructure. So we basically observed kind of a low maturity level of the available infrastructure components. What does this mean? These are actually usually prototypes. They are limited to some project, limited to a partner, and if they are developed to a higher TRL level, they are usually difficult to interoperate with. And the effort to translate them to a different environment, to a different domain, to a different, even in the same domain, but just a different industry process is very difficult. Then this might sound trivial, but especially because we want to to support standardization, we don't see low-level ontologies. You know, think of the entire international system of units, yeah, which is you need to communicate distances, you need to communicate temperatures, you need to communicate sizes, and there is no basic low-level ontology which would just allow you to build your higher-level ontologies on this one. So we believe that this is central to developing standards for interoperability. Another gap is, I think I will go a little bit faster through them. This ontology data provisioning, what does this mean? How do I access this data in a way that is useful for me? How is it good for me to maintain the data I have been created? What kind of APIs do I have for maintaining it, modifying it, maybe even retiring it if I don't need it anymore? And this should be possible to do outside of the environment where the data was created. Federated interconnected virtual research environment. This is also one of the topics that IOSC and IOSC Association tries to address in their efforts. We want to go towards scalability and especially address the issue of evolving hardware, data management, curation. This is, of course, of uppermost importance. We've heard this morning from Evgeny that we need this end-to-end applications and examples to show how the things work, and also a description of this end-to-end applications so that they can be translated to different areas. Maybe the last one, which I would really want to underline, is there is not sufficient support for transfer from R&D to departments and there is no funding stream to establish whatever prototypes and work we have created during our research to translate it now to a running service, which now presumes completely different set of skills, completely different needs than what we as researcher created, and that is not there. How much time do I have? Okay, recommended actions. So from all those gaps there, this would mostly contribute to fill those. The low-level ontology development would contribute to avoiding the misinterpretation of implicit knowledge. Secure platforms for ontological data, creation, provisioning, exchanging, and something which I think it's also important, virtual research and innovation environments. Some of them do exist in astronomic research and biomedical research like Elixir, and it would be good to learn from there and create a blueprint for domains covered in OntoCommons. I think that's it.
Thank you. All right, so now let's link with the industrial applications. So I will ask Anna to present. So most of this, let's say, input is coming from the 22 industrial use cases. So it's really related to the application. So please go ahead.
Thank you. So I'm not going to say anything completely new because all of this that we collected in the industrial applications kind of flew into all the other topics in the project. And but I'm going to highlight a few of the industrial needs and the gaps and the recommended actions that we found. So on the industrial needs, one of the most important things is people lack some communication, common language to talk between different stakeholders. So we need to ease this. This perceived ease of interoperability is not there. People need to have this common language to communicate. There should be some best practices on how to maintain data models and intuitive tool support. On the data dimension, Also, it's not easy to use and understand ontologies such as they are, and they need to be applicable without much explanation, without improved reusability of this metadata and processes is also a need that is perceived by all industrial applications that we talked with. And on the processes dimension, we saw that costs, time saving is one of the main topics that the industrial partners have, and they to save resources, they would need some help and have some increased automation in the tasks of decision making. And so the gaps that we found were, the learning barriers perceived at the moment to learn all of this semantic technology in industry is very high, because people struggle to find trained persons that know about data, how to manage all ontologies and taxonomies and whatnot. Also, there are very high costs in ontology development, also derived from this learning barriers. So if you need a lot of time to train somebody in develop an ontology, then this is going to incur in very high costs. And ontologies are still difficult to maintain, also, this company internal and partner interaction should be optimized, because at the moment we are still talking about this common language is missing. So people still they would need some kind of translator between the companies talking. One has a higher level on the ontology domain, the other not so much, and this is difficult to leverage at some point. The ontologies are not well documented, the ones that they can find. Even there's a lack of comprehensive domain ontologies in all these domains that we are talking about, manufacturing and materials. People cannot find ontologies, maybe because they are not well documented, and in the internet or in whatever repositories they are. And they also don't understand what are the arguments for using FAIR principles. Why do I need to make my data and ontology findable, accessible, interoperable, and reusable? This is still not clear to the people using things. So also some of the gaps are the lack of so dealing with content that is protected with IPR, so people cannot actually use or at least publish some of the results that they are using, or because of some IPR issues. And this leads to, okay, the ontology should follow higher level ontologies, and there should be, so that they can be then also interoperable in between the main ontologies. Also on the tool domain, some user interfaces can be not so comprehensible for people who are using or trying to develop an ontology for the first time. And tools for ontology engineering are not complete, or at least people they have to be paid for, and most of the times people just end up with Protégé, and it's not very user friendly, or the maturity of the collaborative tools that exist. It's not very high, and okay, I'm here, my colleague is in another company, and we are trying to develop something together, but the tools don't help. Yeah. And let me just highlight some of the recommended actions that we found. So very important would be some knowledge engineering education. So to have some methodology, some training, some best practices, demonstrate on how you can use the ontologies to save time and costs in when working with all of these topics. So maybe some having some success stories would help. Have some networking events where all of this can be brought to shared, and all this experience on ontology adoption can be shared, and highlight the advantages of ontology use. So maybe somebody told a person that, okay, you should use ontologies to help on your daily process, but they don't actually know why they are doing this. So maybe this should be brought into attention. So then on the data side, you should have some data sharing and standardization of ontologies, and demonstrate, still on the demonstration and best practices, demonstrate the FAIR benefits and how to apply the FAIR principles also for metadata, close cooperation with FAIR communities, and yeah, on the tool side, increase user friendliness and support collaborative development of ontologies.
Thank you, Anna.
Thank you.
So as you can see, I mean, there is a lot of overlapping between the chapters, because it's driven by the community. And one of the most important topics that Anna highlighted is standards. So I invite Christina to talk about standards.
Thank you. Hi, everyone. And yeah, so first of all, I try to be very short because I want to leave some space for questions. And I've seen some comments on screen, which I will later show. As Heidi was rightly saying, standardization is a crucial topic for OntoCommons. And in fact, we saved a full day tomorrow for sessions on standardization. And we also have an entire chapter of the roadmap dedicated to standardization. And in particular, in OntoCommons, I think we're lucky on many points of view. First of all, because during the period when OntoCommons was already started, it started in 2020. Then it was I think 1 year after, it was February 2022, 2 years after, that there was the EU standardization strategy. And one important concept was that Europe must be a rule maker and not a rule taker in terms of international rules and standards. And I think this is a fundamental concept, and we need to be realistic. If Europe wants to be a rule maker, it should be realistic in the sense that only by considering the reality of things, then you can look at what are the real needs and what rules should be implemented. And the best way to look at reality of things would be also to get the feedback from the people who are really using the standards, from industry. And I think it's fundamental that OntoCommons is linked to the demonstrator. And in fact, at the beginning of the project, there were 11, and then we had a whole new set of demonstrators, which I think gives really the opportunity to collect requirements, above all for the NMVP domains. So, and plus being a CSA, and also we have this set of external advisors in OntoCommons that we sometimes like to kidnap and ask for feedback. And we had interviews with many of them, which gave really relevant feedback. And I think that's why OntoCommons really has a lucky position on this. So we highlighted industrial needs, for example, stronger integration of multi-domain stakeholder clusters with digital supported workflows, smart standards. And what I'd really like today, what I'd really like from all of you at home and here in person today is to, of course, have a look at the roadmap on the website. And because now the last version of the roadmap was released almost 1 year ago. It would be great for the new release to also have your feedback on this. What we performed was also a demonstrators analysis. So we mapped all the standards and ontologies used by our demonstrators, and that's how also we were able to get more feedback on what is working, what is not working, what else do we need. In fact, OntoCommons was also cited in the scoping study for supporting the development of code of practice for researcher on standardization, which is also, I think, crucial in the sense that OntoCommons bridge is also between industry and research. So finally, we were able to draft these recommended actions, which really I invite you to add more to these recommendations and to really tell us more. And you can do this through the surveys on the website, but also we have a focus area, we have a contact on the website that you can use if you don't want to stick to the survey. If you have anything to add more than this, please feel absolutely free. And finally, something which has been released very recently is the landscape of ontology standards that was done in collaboration with the Standard project, thanks to the work of Arco, Hedy. And so this is a very deep analysis and database of the ontologies standards. And
thank you.
Thanks.
All right, so we are, I think, running out of time. So I will skip 2 chapters. One is the knowledge management translator for Industry Commons. It's important because we discussed about this need regarding having skills and training. So this chapter is focusing on that, and what we are recommending is to build training, to build let's say a new job profile for translator that make the link between the different business domains, the technical aspects of ontology. So this is one of the recommendation in order to answer this needs and to bridge the gap. That's what we highlighted. So this is the job description. We are working on that, and also we are, let's say, preparing materials for training to establish this translator profile, let's say that, and also we recommend to have tools in order to help on that. The next chapter is on the let's say the cooperation with digital marketplaces, how ontologies can play a role. What is, I mean, let's say, what are the needs from marketplaces perspective. So this chapter was presented in the previous workshop in Berlin. So I will invite you to have a look on the videos describing this. And I will invite Michela to talk about a very important chapter, which is innovation and perspectives.
Thank you, Hedy.
So the first thing I think we'll start with is to distinguish between different types of innovation, because of course, in terms of industry needs, the need for innovation is not something that's contested, but what kind of innovation do we need? So according to Pisano, this is Harvard, the Harvard classification of different types of innovation, which I think is really useful as a starting point. The incremental innovation in industry is considered routine. This is what regularly happens. Technological innovation is considered to be radical because it builds new competencies for existing business models. Disruptive innovation is where new business models are proposed based on existing competencies. And if you use both radical and disruptive, then it's architectural because you're changing everything. And this one's the most risky for industry. So it's worth referring to this when we actually consider what kind of innovation we're dealing with. And it's also worth noting that any significant breakthrough will always fracture established organizational learning patterns. And this is why it's such a big risk for industry, because radical innovation, as in technological innovation, will destabilize existing capabilities. So it means renewing capabilities. And disruptive innovation, as in business innovation, may disengage existing customer bases. So this needs to be managed really, really carefully. Otherwise, we may end up with losses of profit. So when we go from breakthrough innovation that we identify as occurring in the gaps between the different domains, where there is a huge amount of potential of innovation, to where we integrate them across the full value network across domains, something that's fully integrating will require inherently, according to these classifications, new organizational learning patterns and update of knowledge exchange practices. And this is where OntoCommons really helps with this process. Is it stuck on arrows? Oh, that's just gone through several now. Okay.
This one?
Yeah, I think so. So the industry commons ecosystem approach then looks to create a series of enabling horizontals that cut across industry verticals. And data interoperability obviously is the main one, and this is where OntoCommons comes into it. And it's supported by a whole series of others, such as financial services, intellectual property tracking, legislation or regulation, environmental monitoring, corporate social responsibility, and of course societal values, things that for instance, involve embedding our societal principles such as inclusion, where we look at, for example, data biases, all embedded in these systems. So this is the mapping of the industry commons. Now, if we look at what are the preconditions for the interaction across domains, if we look at enterprise integration as a starting point of something that unites all different capabilities inside industry, and we are now working across domains, so it's even bigger than the traditional enterprise integration. What we really need is we need to be sufficiently transparent to allow everybody to have a clear view over the whole system so that they can make the right decisions. So sufficiently transparent means that we don't reveal everything. This is a bit like the misconception in open innovation, where people think that everything's open and free for all and nobody makes any profit then as a result of it, or nobody owns any IP. Far from it. What we're saying is sufficiently transparent so we can make the right decisions. Technologically harmonized, this is where OntoCommons really comes into it, and allowing interoperability and reference documentation across all of the actors' technological components. But also, as we said before in the enabling horizontals, we need to be effectively supported by responsible societal and environmental parameters that need to be embedded in the system. So we don't end up with some of the problems that we have experienced with the large platform implementations in the past few years. How does then innovation build on top of this? So here's a useful use case. We take two data sets. If we get data sets from two different domains, we can combine it we can model data sets in a new use case. And we generate a new data set that indicates new market possibilities. What happens when the system is fully integrated across verticals? The system can notify the proprietor of any of these data sets of of the results of the new simulation. And of course, they can make informed decisions based on this notification. This is the first time that we're embedding breakthrough innovation into a system like this. Usually breakthrough innovation was happening in the sidelines and it could really uproot existing business models or existing practices. In this kind of system, the notification allows for really informed decisions and investments that are related to that. And that means that we enable continuous learning and decision-making control in these huge, complex ecosystems. And we can, of course, integrate all the sustainable aspects and into the decision-making processes so we can actually be sustainable in how we develop this ecosystem. So what are the actions that we are now based on these principles? In OntoCommons, we are now looking at how does this relate to our demonstrators and where are they in respect of these ambitions. So we're looking at best practice for expansion across domains. We're looking at potential novel business models. The role of interfaces is particularly being addressed in the prototyping lab, which we are running all week this week, and you will see the results of it on Friday. But if any of you are interested in how we are looking at creating more decision-making ability, more transparency, and more usability with these new interfaces, you can join us in the prototyping room, which is in the postscript room up the stairs at the end of the hallway. And also the positioning of the OSAS within cross-domain data-driven landscape. This is, we will show you also on Friday some breakthroughs that we've had with expanding OSAS into other domains or combining it with other capabilities. So I think we're seeing some of the first results from some of these investigations of combining these ambitions with some of the actual things that are happening within OntoCommons. Thank you.
Thank you, Michaela. Right. So yeah, let's conclude regarding all what we presented. So I tried to do this exercise of find let's say common thoughts regarding the industrial needs, the gaps, and the recommended actions. So I tried to summarize from an industrial perspective. The needs are more on the data integration and sharing, and for that they need on effective data documentation and standardization. There is different domain perspectives, so we need to train people on ontology engineering to have trust, let's say, trustworthy data repositories and trusted computational. Also to link the domain expert with ontologies, and the gaps are on different aspects on the engineering aspect, but also on the tools perspective. So gaps are identified, especially from the user-friendly and collaborative perspectives. So this is a highlighted lack. Also, the lack of understanding of fairness to well explain difference between fair doesn't mean that it's open. So this is very important, and this is a gap because people, they don't understand really the difference. For recommended actions, so what we recommend from the different chapters is to work on the standardization, and especially the ontology engineering steps, to have also the balance between theory and practice. This is important to bridge the gap between people working with data with real applications in industry and people working on ontologies. So this is very important. Also, what we need and what we would have to work on is the ontology scalability regarding the expressivity and the computability, to work on the fairness by design. So for that, we recommend to have tools for that. And let's say in OntoCommons, we identified those recommendations, those gaps and needs, and we try to come with answers. So in terms of tools or methodology. So for that, we need your help, the community help. All the what we developed or what we identified in the roadmap came from the community, from the different stakeholders, and we need more input from your side, more participation. So we have an open consultation in order that all the community be active on the roadmap. So I ask all of you to go to the roadmap page, to have a look on it, and also to answer a survey. So for each chapter regarding the needs, the highlights, but also what we missed, what we didn't identify, and also to make priority and the time scale regarding the action. So this is very important. The objective of this roadmap is to have a clear view for the future, also to, let's say, one of the most important topics that people discuss about is funding. So this roadmap is also addressed to the policymakers. So if you would like to work on ontologies, if you identified problems, so this is the opportunity to express yourself and that your voice be on the let's say on the office of policymakers. Okay, so thank you very much for this session. If there is some questions, please go ahead. We have, let's say, 5 minutes to do that before next session. I don't know online if there is questions or in the room. Yeah, so yeah, regarding the availability, that's why what I said. I mean, we started to do actions regarding the gap. So industry portal is an instance of Onto portal technology, and this is a dedicated repository in which you will find ontologies and with other features in order to answer the gaps identified in terms of tools.
Any questions from the room?
Okay, anyway, the most important, please go to visit the website to have a look on the roadmap and provide your input. I see that there is a question from Sir. Yes, go ahead.
Can you explain more on what is the virtual research and innovation environment? Seems to be very broad. I think of like this is also virtual research. So I don't know.
Sorry, I didn't understand.
Somebody mentioned about the need to create a virtual research and innovation environment. So just
virtual. Yeah, the study channel. What does it mean?
Yeah.
Who mentioned
that?
This was in the infrastructure part.
Yeah.
There is a virtual research environment, which
Yeah.
means you have a distributed set of infrastructure tools. Not only EOS. Yeah, you have. It can be cloud-based, it can be AI involved there, so authentication, single sign-on, and everything. So it's virtual in terms that you are not in the lab, on-site, work together, but you have some environment where you log in, you can run your experiment, you can access data which is somewhere completely else around the globe. Maybe push your algorithms there to the data, get the results back, and then continue. So this is virtual research environment. And if you look at Elixir, is a biomedical research environment which is very, very active right now. They have very good documentation on how to use it. And this addresses also the question of I don't have the resources as a researcher to run the computations. I can access such an environment, access data somewhere else, and run my code, and then evaluate it afterwards.
Thank you.
Perfect. Okay, thank you very much. So let's conclude this session and move to the next one. Okay, I will invite Martin that will share this session.